The histogram gives information about the speeds of some cars on a road. Work out an estimate for the median speed. Okay, so remember the median is the middle number, so the middle speed. So I need to find the speed where half of the cars are below that speed and half of the cars are above that speed. So for example, if it was, let's say it was 65, that would mean that half of the cars were on this side and half of the cars were on this side. Remember, with a histogram, it's the area of each bar that represents the frequency. So I need to find the speed. So if it was 65, we can see clearly, actually, that it's not. We can see that the area over here is much bigger than the area over here. So maybe it would be like that. Maybe that's the point where the area here is equal to the area here. Well, it's not going to be that. I'm going to tell you right now, it's not going to be a nice, easy whole bar. It's going to be somewhere in the middle, maybe here, or maybe here. It's going to be awkward. Anyway, so that's our method for working this out. We need to find the point where the area over here is equal to the area over here. So first of all, let's just work out the total area of all of this, and then we can divide it by 2, and then we can figure out the point where we've got half of the area on one side and half of the area on the other side. So I'm going to do a bit of rough working out to get the total area here. So let's just focus on the first bar. So bar 1, the first bar here, the area, I'm just counting the squares, I'm not doing anything fancy here. So 1, 2, 3, 4, 5, 6, 7. I've got 7 full squares, and then I've got 1, 2, 3 fifths of a little square here. So 7 and 3 fifths, which is the same thing as 7.6. Bar 2, I can see I've got 3, 6, 9, 12, 15, 18, 21, 24, 27 full bars. And then I've got these little extra bits on the top. So I've got 2 fifths here, another 2 fifths here, another 2 fifths here. So that's 6 fifths. So I've got 27 full bars and then 6 fifths, which is the same thing as 1 and 1 fifth. So the 27 and the 1 would be 28, and then the 1 fifth is 0.2. Okay, bar 3. 2, 4, 6, 8, 10. So I've got 10 full squares, and then I've got 3 fifths here, 3 fifths here. So that makes 6 fifths, which, as we said before, was the same thing as 1 and 1 fifth. So this will be 11 and 1 fifth, which is 11.2. And then finally, bar 4 over here, we've got 1, 2, 3, 4, 5, 6 full squares. And then we've got 2 fifths, 4 fifths, 6 fifths, 8 fifths, 10 fifths. So 10 fifths is actually just 2, isn't it? 10 fifths is 2. And another 2 fifths. So we've got 2 and 2 fifths there, which is the same thing as 8 and 2 fifths, which is 8.4. So we've, just by counting these squares and being a bit careful with the fractions, we've worked out the area of each of these bars. If we now add all of those numbers together, we will get 55.4, I think. So the total area of all of these bars is 55.4. I'm going to half that, because remember we're looking for the median here. So if I half that, I'm going to get 27.7, I think. I'll divide that by 2. So I'm looking for the point, to remind you what I'm doing here. I'm looking for the point here where I've got 27.7 squares on this side and 27.7 squares over on this side. That's what I'm doing here. So I'm guessing it's going to be somewhere around here. So I'd have 27.7 squares here and 27.7 squares there. you'll notice there's no units on here, which is fine for this question, because it doesn't matter what one square is worth when we're doing this question. It doesn't actually matter how many cars there are in total, because one square here is going to be this equal to one square over here. What that square is worth, it doesn't actually matter. So that's why it doesn't actually matter that we've not been given the frequency density. So yeah, anyway, let's go on with actually solving this problem then. So we need 27.7 squares over here. We know that there are 7.6 squares in the first bar. So we need, if we take 7.6 away from our 27.7, then that's going to give us 20.1. So we've already got 7.6 squares here. We need another 20.1 squares, and then we will have got to our median point. Just again, to repeat one more time, we're looking for the median value somewhere about there, where we've got 27.7 squares over here. We already know that's 7.6 squares, so we need to count and find 20.1 squares here. Because we know the total area of this bar is 28.2. That's the total area of this bar. So we know 20.1 is going to be within that. We just need to find how far along. Well, what fraction of this bar do we want? The fraction of the bar we want is 20.1 out of 28.2. We want this many squares out of the total of this interval, and then we will know how far along, what fraction along we need to go to get to our median point. And if we do that, if we do 20.1 divide by 28.2, we get this awkward fraction, so basically just over 71%. So our median is going to be 71% of this bar. The bar is 7.5 squares wide, from 5 to some 55 to 60, that's 5, and then another 2.5. So this bar is 7.5 squares wide. We want 71% of that, so let's times that by 7.5. And there we go. We know the width of this bar that we need in order to get this to be the 20.1 squares is 5.34. Actually 5.35. I'll write it all down. So we found then that our median is roughly about here. And that is the point 55 plus this answer here, so I'll add 55 to that. The median speed is 60.3. And that is your answer. And if I were to count up all of these squares here now, I would get 27.7. And if I was to count up all of these squares now, I would get 27.7. So that is how you find the median from a histogram. You need to find the points here where you've got the same number of squares here as you do over here. So you work out the total number of squares. You divide that by 2. You then find how far along you need to go in order to have that number of squares here, and you do that by taking away the full bar that you know, then work out the fraction of the bar that you're left with and multiply that fraction by the width to find out how far along that bar you should go, and that will tell you what this value here is.